Right then, in this explainer, we're going to get our heads around a really fundamental concept for your GCSE Computer Science studies: how devices on a network actually find and talk to each other. It's absolutely key to understanding how the internet works, so let's dive straight in.
So let's start with a big question. When you go to a website, your computer is sending data out onto this massive global network with billions of other devices. How on earth does it make sure that data gets to the exact right place and not somewhere completely random? Well, that's the question we're going to answer.
The answer all comes down to a pretty simple idea. Every single device needs its own unique identifier. You can think of it like houses on a street. If two houses have the same address, the post would get mixed up. On a computer network, it's even more important to get this right. So to avoid any confusion, computers don't use names, they use unique numbers to make sure data is delivered precisely where it's supposed to go.
So that's where two really important types of addresses come in. You've probably heard of them before: IP addresses and MAC addresses. We're going to take a look at what each one is and the very different but equally important job that each one does.
First up, we've got the IP address, which stands for Internet Protocol Address. Now, it's known as a logical address, and that's a key detail to remember. It basically means the address is given to your device by the network it's currently connected to, so it can change. Say you take your laptop from your home Wi-Fi to a local coffee shop, it'll be given a brand new IP address. Its main job is to act as the global address for your device on the internet so other computers know where to send data.
The most common format, the one you'll see most often, is called IPv4, and it has a very specific structure. It's always made up of 4 numbers, and each one is separated by a full stop. Now, the crucial rule to remember is that each of these 4 numbers has to be somewhere in the range of 0 to 255.
And we can see that rule in action right here. The address on the left, 10.0.0.1, is perfectly valid because every number, 10, 0, 0, and 1, is inside that 0 to 255 range. But look at the one on the right, 300.4.12.9. That one's invalid. Why? Because that very first number, 300, is too big. It's outside the allowed range, so it breaks the rule for IPv4.
Now here's something important to know for your studies. The world is actually running out of available IPv4 addresses. There are just so many devices now. To fix this, a new version was created, called IPv6. Its addresses are much, much longer, which allows for a mind-boggling number of new devices. For your exam, you don't need to memorize the IPv6 format. You just need to be aware that it exists and that it's the solution to the IPv4 problem.
Okay, so what about that second type of address? Well, that's the MAC address, which stands for Media Access Control. Now, unlike an IP address, a MAC address is physical. It's a unique serial number that is literally burned into the network hardware, like the Wi-Fi card in your laptop, by the manufacturer when it's made. And because of that, it doesn't change. It's fixed to that specific piece of kit.
Right, let's put them side by side and quickly recap the key differences. An IP address is logical. It's assigned by the network you're on, and it can change. Its main job is routing data across the big, wide internet. A MAC address, on the other hand, is physical. It's set by the manufacturer and it's fixed. Its job is to identify a device within a single local network, like all the devices connected to your Wi-Fi router at home.
Okay, so we've got these addresses, but that brings us to the next piece of the puzzle. We know that computers need IP address numbers to talk to each other, but that's not what we use, is it? We use names. And this creates a kind of translation problem that needs a very clever solution. I mean, think about it. It's far easier for us to remember a name like google.co.uk than it is to remember a string of numbers like 142.250.178.227. But as we've just learned, the computer absolutely needs that number to find the right server on the internet. So, there has to be some kind of system that translates the name we can remember into the number the computer needs.
And that system is called DNS. It stands for the Domain Name System. And its one and only job is to do that exact translation. When you type a website address into your browser, DNS is the service that looks up that name and finds the matching IP address for your computer.
Probably the best way to think about DNS is like a giant phone book for the internet. You know, back in the day, if you wanted to call someone, you'd look up their name in the phone book to find their number. DNS does exactly the same thing, but for websites. You give it a name, and it gives you back the IP address number. Simple as that.
So, what does this lookup process actually look like in practice? Well, it's a sequence of very clear steps that happens in the background in just a couple of seconds every single time you visit a new website.
Let's walk through it step by step. It all starts when you type a URL into your browser. Your computer immediately sends a request to a DNS server, basically asking, what's the IP address for this name? The DNS server then searches through its records to find the match. As soon as it finds it, it sends that IP address back to your computer, and finally, your web browser can use that IP address to connect directly to the web server and start loading the page you asked for.
Okay, so we've covered quite a bit there about addressing and how names are translated in numbers. Let's just quickly summarize the most important points that you'll want to have for your revision.
Try and lock in these 4 key ideas. First, every device on a network must have a unique address. Second, IP addresses are logical addresses for routing data across the internet. Third, MAC addresses are physical, fixed addresses for identifying hardware on a local network. And fourth, DNS is that vital system that translates website names into IP addresses.
So if there's one big idea to take away from all this, it's this. Computers are built on a system of numerical addresses to identify devices and send data correctly. The domain name system, or DNS, is the essential bridge that lets us humans use memorable, friendly names to interact with that number-based system.
Right, to wrap things up, let's just quickly test what you've taken in. Have a think about the answers to these 3 questions. First, what is the main purpose of an IP address? Second, which of the 2 addresses is the physical one, IP or MAC? And finally, what does DNS actually do? Answering these will really help to make sure you've got a solid grasp of today's topic.